Hi everyone, now we're moving on to problems with 3D shapes. So exercise 6G, I'm going to do question 1A and 1B for you guys so that you guys can then have a go at question 2A and B. So to start off, let's have a look at this diagram. The cube shown has side lengths of 13, so that means all of these side lengths would be 13 because it's a cube. Find BD. So I want to find this diagonal length here. And the way I visualize it is I know that this length of AD is 13 and I know that this length of AB is 13. So if I zoom in a picture here of what this triangle I just drew looks like, I would actually, because that's a right angle triangle, so we know that this length is 13, this length is 13, and let's call this length x. So we're trying to find, I would actually use Pythagoras, a squared plus b squared equals c squared to solve this. First thing I want to do is label my A, B, and C. So this length is A, this is B, and this is C. And now I'm going to put in my values. So I've got 13 squared plus 13 squared equals c squared. That means c squared is going to be 338. And then last step here is to get rid of squared, we use square root. So the square root of 338 is 18, approximately 18.4 centimeters. Sorry, that should have all been x because I labeled it x. So x is 18.4 centimeters, which means this length of BD is 18.4 centimeters. The part B asks me to find, I'm going to use a different color and I'm actually going to erase this so you can see a bit better. So let's use this blue. So it's asking me for angle FDB. So it's really looking for this angle here. All right, so I know this height here is going to be 13 and I know side length BD is 18.4. So if I'm looking at my angle and this bit here makes a right angle, I'm going to be looking for so I've got my angle here, I have my opposite side and my adjacent side. So I'm going to be doing tan theta is opposite over adjacent, and tan theta is 13 over 18.4. Then I'm going to do the inverse of tan, so theta is 10 to the minus 1, 13 over 18.4, which comes out as theta is approximately 35.2 degrees. So that's all of question 1 solved. So this one was 35.2 degrees. So you can now use this example to have a go at question 2A and 2B. The other question I'm going to have a look at in 10G, I'm not going to do this one for you guys, but I am just going to set you up for it. So question 3, it says an open cone has a vertical angle, so this full angle here of 40 degrees, and a base radius of 30 centimeters. So remember your radius is this length here, so you get a radius of 30. It wants you to find the height of the cone here. So you're looking for the height. Your angle in this triangle now is going to be half of that, so your angle is going to be 20, and you have your opposite and your adjacent side length. So you should now be able to rearrange using tan to find the height. Part B then says find the capacity of the cone in litres. because you're working in centimeters, so what you'll need to do is you'll need to find the volume of the cone in centimeters cubed, and then 1 centimeter cubed is equal to, no, sorry, that's wrong. 1,000 centimeters cubed is actually equal to 1 liter. Now, to find the volume of a cone, I'll just give you that bit of information. Hopefully you still remember it. It's 1/3 pi r squared times by the height. So yeah, let me know how you go with question 3 as well. Good luck.